Mark your own. Here we go. There's going to be an Atwood machine. Find the acceleration. This is a job for a. What are the forces acting on it? I got M1G tension, M2G tension. Who's winning? For an Atwood machine, it'll generally be the heavier mass. So that's the 21.3. M1, I'll make a little note so I don't forget, Gabor. I'll do that just so I know that's which way we're accelerating. And now I can get my equation. It looks like it's going to be winner minus loser. And then when I go around, this tension pointing up was a loser. This tension is pointing up. You might think it's also a minus loser, but when you follow it, I think when it gets to this side, it's pointing down. Yes, yes, yes. So it'll be winner plus and minus M2G. That equals M all A. Love it when I lose tension. How would I get M all by itself? It's going to be A equals M1G minus M2G all over M1 plus M2. Now we plug in numbers. A is going to be M1 21.3, G 9.8 minus 19.6 times 9.8 all over 21.3 plus 19.6. I'm guessing you got a really small acceleration. I may have mentioned this on Friday, but Jay, what's the first mass? How big is M1? 21.3. How big is M2? If M2 was 21.3, what would the acceleration be if they were both identical masses? Zero. These are nearly identical. I'm guessing you got an answer definitely less than 2, probably less than 1. Am I right? Okay. Now, so it gives me a bit of a built-in error check. I looked at the question just in case I made a typo. I get 21.3 times 9.8 minus 19.6 times 9.8. Close off the top. Divided by bracket 21.3 times Mr. Dewick. Plus 19.6. Check for typos. Looks good. You get 0.407? Okay. If you got that, 4 out of 4. More specific, please. I'll take that. I would use your answer button on the next one, though, because if you use the rounded off answer for part B, you're going to be even more off. Yep. Otherwise, I would give you 1 mark for this, 1 mark for dividing by acceleration. If you did it on that line or on that line, I don't care, but I've done both. I've just done it right away, or I've rewritten the equation. 1 mark for the numbers and 1 mark for the answer. Find the tension. I'm going to find the tension using, I don't know, tension mass 2. If you use tension mass 2, you'll get tension minus M2G equals M2A. You'll get tension equals M2A plus M2G, which is going to be M2 19.6, A 0.407, plus 19.6 times 9.8, 19.6 times answer button plus 19.6 times 9.8. You get 200? I figured it was going to be a pretty big tension because 21 kilograms and 19.6 kilograms pulling on either end, that's almost 100 pounds of mass. That's going to be a fair bit of tension. This is lifting a fair bit. So before I do that, 200 newtons. If you used mass 1, you would have M1G minus tension equals M1A. You would have tension equals M1G minus M1A. You would swappy dance and also get the 200. So regardless, I would give you 1 mark for that, 1 mark for getting the T by itself, 1 mark for the answer, 1 mark for that, 1 mark for getting the T by itself, 1 mark for the answer. Did I answer your question okay? Yeah. Got to give me time to get there. So there's going to be an Atwood machine, and I'll probably make it, you can see, because you can see it's a number of steps. I'll make it worth 5 or 6 or 7 marks, probably 7, because that actually works out really nice. Is that meaning that it's really hard and difficult? It's a lot of steps, Hannah. I hope it's not free marks, but I hope for you it's guaranteed marks as long as you don't make a silly mistake. There's going to be one like this. Why is this one so tough? How can I glance at this and go, ugh? Oh, there's an extra vertical force in the picture. Normal force is not mg. This is a job for a free body diagram. What are the forces acting on it? So I'm still going to have mg. There is going to be a normal force up because it's not sinking into the ground like quicksand. It's not flying through like Superman. Normal force is going to be bigger, smaller, or the same? Not the same size. There's an extra vertical force. Normal force is going to be bigger or smaller than mg. It's going to be smaller. I'll really exaggerate it. Then I have F applied and friction. A common mistake I see, kids say that friction is 0.48. Is this a force, this 0.48? No, it's not in newtons. What's friction? This times the normal force. The 0.48 helps us calculate friction, but it's not the force of friction. That's why we call it the coefficient of friction. It's the number that goes in front of the normal force, like a coefficient. Who's winning? I'm pretty sure F applied. Who's losing? Friction. What's that going to equal? MA. A is going to be F applied minus friction over M. Friction is what times what? I don't know the normal force. And unfortunately, I can't just say, oh, but look at another force same size as a normal force. Now, you might be able to see this in your head, and if you can, great. But when I'm in doubt or on a quiz or on a test, I'll actually write an equation, and I'm going to do that right over here. I'm going to say everything down has to equal everything up. And everything down is mg, everything up is a normal force and a 19. Except instead of and, what did I write? Plus. How would I get the normal force by itself here? I guess the normal force is going to be mg minus 19. If you calculated it, you would get 3.6 times 9.8 minus 19. You would get 16.28. I'll write that here. Oh, and this one page I would not round off because I'm using it to find an answer. I'm actually going to just not even bother calculating it. I'm going to do this in one step. I'm going to say A equals F applied 12 minus mu 0.48 times the normal force mg minus 19, although instead of mg, 3.6 times 9.8 minus 19. All over 3.6, because I'm kind of lazy, and also I like Nicole to show off on my calculator, so if I can do it in one step, I kind of try to. So it's going to be bracket 12 minus 0.48, open up another bracket, 3.6 times 9.8 minus 19, close off the friction normal force bracket, close off the top, divided by 3.6. Do y'all get 1.16? No? Yes? Yeah? People nodding? What if I had gotten a negative answer? Who'd be winning? Friction, I would redo this. Friction minus F applied equals MA. And that would mean this object was slowing down if it was moving, or if it wasn't moving at all, then it's going to stay at rest until I pull hard enough to overcome friction. For 3 marks, I would probably give you half mark if I saw that, 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 half mark for the numbers, and a half mark for the answer. Something like that. What would the acceleration of the mass be? Okay, this is a job for a free body diagram. mg, normal force. You know what? There's two applied forces. I decided, oh, F1 and F2. So I got F1, I got F2. Oh, who's winning, F1 or F2? Winner minus loser equals MA divided by M. 60 take away 36 is 20. Is it 2? Yeah? I did the math in my head. They're doing clay upstairs, I think, so that's okay. I'm loud enough, I will never complain about somebody else's noise, because I'm crazy loud. Draw a free body diagram. Okay. mg, normal force, F applied, friction. How many lines did I draw? How many marks is this worth? How about a half mark for each line? Now here's what I need. Your normal force and your mg should be about the same size, and F applied should be bigger than friction in this case. Find the acceleration. Okay. Who's winning? Who's losing? Friction equals MA. A is going to be F applied minus mu times the normal force. I don't know the normal force. Oh, but look. I know the force same size as the normal force. A is going to be F applied minus mu mg all over m. It's going to be 225 minus 0.15 times 100 times 9.8 all over 100. Do you get 0.78? Oh, barely accelerating at all. We're almost in balance. Not quite. Is it 0.78 even? Don't forget your units, meters per second squared. If you got that, 2 out of 2. Otherwise, I would give you a half mark if I saw that, a half mark if I saw that, half mark for the numbers, and a half mark for the answer. Ooh. Find the acceleration. This is a job for a free body diagram. What are the forces acting on it? M1G, normal force number 1. Since there's more than one mass, I'll call it normal force number 1 to go with mass number 1. Tension. Oh, friction. And again, Wolf, I'll call it friction force number 1 to go with mass number 1. Here, M2G, tension. Is there a normal force under M2? Nope, it's not sitting on a surface. Who's winning? So there's no way that a box on its own will just start crawling left, lifting this up. Either friction is so big that no one's winning, I'll find that out if I get a negative acceleration, or we're accelerating right and down. So I think this is what's causing this whole thing to start to accelerate. I had somebody say to me, Mr. Dewick, this is impossible because this is smaller than that. The 4.6 doesn't have to be bigger. M2G just has to be bigger than friction force number 1. M2G has to be bigger than mu times normal force number 1. M2G has to be bigger than mu M1G, and it'll slide. If there was no friction, I could put a feather here, and I'd have an unbalanced force, and it would slide. At least in theory. Find the acceleration. So it's going to be M2G minus tension plus tension minus friction force number 1. That equals M all A. Good stretch. A is going to be M2G minus mu times normal force number 1 all over M all M1 plus M2 times A. A is going to be M2, 4.6, G, 9.8, minus mu, oh, I don't know the normal force, but I'm pretty sure it's mg, minus mu, 0.19 times 6.3 times 9.8, all over 6.3 plus 4.6. A is going to equal, bracket, 4.6 times 9.8 minus 0.19 times 6.3 times 9.8 divided by 6.3 plus 4.6. Do you get 3.06? Yep. That's good. You need a distraction, some of you. Find tension. Victor, which mass do you think will be easier to find tension from? This one? This is cluttered and all sorts. I think I'd use this one. I'm going to use M2. Which way is M2 accelerating? Which way is the winning direction? Same answer. Which is the winning force? So writing an equation for M2, that's going to be M2G minus tension equals M2A. I want to find tension. Tyson, swappy dance. M2G minus M2A equals tension. What was M2? 4.6? G, 9.8 minus 4.6 times, all right, 3.06, but you know I'm hitting my answer button. Oh, do you get almost exactly 31 newtons? No, yes? No, it's not? Yeah, okay. If you got that, 2 out of 2. Otherwise, I would give you half mark for that, half mark for that, half mark for that, half mark for the answer. I think I forgot to do the part marks for this one. So for 4 marks, I'd probably go 1, 2, 3, 4, something like that. Ooh, missing mass question. Assuming there is no friction, find the tension in the rope. Okay. I'm going to do a free body diagram for the mass that I know. M1G, normal force number 1, tension. Is there friction on that little car? I think that's meant to indicate no friction with the wheels. So who's winning? Tension. Who's losing? Oh, who is losing? It's a trick question. That equals M1A. Tension equals 4.2 times 3.2. Tension equals 4.2 times 3.2, 13.44. So 1 mark for that, 1 mark for that, 1 mark for the answer. Find the mass of M2. Now I'm going to do a free body diagram for mass 2. That's going to be M2G. Tension. Who's winning? Mass 2 is accelerating down. So M2G minus tension equals M2A. Yeesh. Marika, what am I trying to find? M2? How many M2s do I have? I know, you can look up. You can look up. How many M2s do I have? How many would I prefer? Get them to the same side. I did a little swappy dance. How many M2s do I have? How many would I prefer? It'd be really cool if there was a Math 9 operation that I could pull out of my back pocket and change this from 2 into 1. Is there? What? I can factor? M2 bracket G minus A equals tension. I guess that means that tension ends up being, no, not tension, M2, because that's what I want to get by itself, ends up being tension divided by the bracket, because the bracket is multiplying. M2 ends up being 13.44 divided by 9.8, take away 3.2. Divided by bracket 9.8, take away 3.2. Y'all get 2.04 if I round up properly, yes? And kilograms are the units for a mass. If you got that right, 3 out of 3. Otherwise, I would probably go 1 mark for that. I'd probably go 1 mark if I saw the factoring. Half mark for that. And a half mark for the answer. Can you give yourself a score out of, this was a pretty juicy quiz, what was it, 27?